Welcome to Learning Algebra Conceptually. Module 1. Introduction. How we will work in this course. Course structure. Overview of the modules and the progression from foundational concepts to more advanced topics. Learning methods. Video lessons explaining key concepts step by step. Practice problems with guided solutions to reinforce learning. Real-world examples show practical applications of algebra. Key tools. Video lectures with key concepts, introduction to mathematical models for thinking. What is algebra? In general, we can say that algebra is about creating, expressing, and defending mathematical relationships and generalizations. Sound difficult? Let's look at an example. If I add two even numbers, it looks like my sum is also even. Will this always be true? The first step is often to test several examples. We see that for these three examples, the hypothesis is true. But examples alone aren't enough to prove a pattern. Let's use a grid model to visualize. An even number like 4 can be represented as 2 rows of 2. Similarly, 6 is 2 rows of 3. When added together, the result is still an even number. If it weren't, a single brick would be left over, which isn't the case. To generalize, all even numbers can be written as 2 times another number. For example, the even number 4 can be written as 2 times 2. The even number 6 can be written as 2 times 3, and so on. We can therefore use this drawing method to defend the hypothesis. In algebra, we show that a case always applies by using letters instead of numbers. This can be easier understood by looking at the drawing. We create two even numbers. We don't know which even numbers they are, but since they are even numbers, we know that the two even numbers can be written as 2 times another number. We call the two numbers n and m. They are placeholders. They hold the place of the real numbers, since we don't know what they are. The two even numbers are then given names, 2m and 2n. The two grid models can still be put together, without leaving a brick left over. The sum is therefore an even number. Algebraically, the sum of the two numbers is 2 multiplied by m plus n. We write this as 2 multiplied by brackets m plus n, or just 2 brackets m plus n. Some magic tricks are just algebra in disguise. Try this trick yourself. First, think of a number between 1 and 10. Once you have it, double that number. Then, add 8 to your result. Now, take that new number and divide it by 2. Finally, subtract the number you originally thought of. Do you have your answer? Think of your answer, and I will read your mind. Is your answer 4? How does the trick work? We can explain it using algebra. First, you are asked to think of a number between 1 and 10. Let's imagine a purse. We can think of the number you are thinking of as the number of coins in the purse. I don't know how much money you have in your purse, but I know that it has between 1 and 10 coins. You would then multiply this number by 2. That would mean one more purse. I still don't know how much money is in the new purse, only that it has the same number of coins as the first one. Then you add 8, so we add 8 coins. The next thing you had to do was divide by 2. Then we must take away half of the coins and half of the purses. The last step was to take away the number you started with. I don't know how much money was in the purse, but we're taking it away. What are we left with?
4 coins.
The number you thought of.
Cool, right?
In algebra, we use letters instead. We can show how the trick works with letters instead of pictures. First, you thought of a number. I don't know what number, but we'll call it P for purse. By multiplying by 2, you got 2 purses. We write that as 2p. By adding 8, we got 2p plus 8. When we divide by 2, we must have both the number of purses and the number of coins. That gives us p plus 4. Finally, we must subtract the number we started with. The number we started with was p. If we take away p, we're left with 4. Algebra can help us discover patterns and regularities in the world around us. Algebra provides us with a way of systematically thinking, exploring, and arguing in mathematics. Algebra provides us with a language in which we can make argumentations and proofs. Algebra is fun. In algebra, we have many letters that we use for different things. In mathematics, we have some conventions about which letters we use when. You can see a small, but not complete overview here. But note that in algebra, we can often choose the letters ourselves, as long as we explain what we mean by the letters we use. Like we did with the magic trick earlier, where we used P for wallet or purse. Another very good way to learn and practice algebra is to study growing patterns. Look at the pattern in the picture. Next, I'll give you 6 tasks. Pause the video and try to solve the tasks before moving on. Can you draw the next pattern figure 4? How many circles will figure 4 have? How many circles will figure 5 have? What about figure number 10? Can you make a conjecture which describes the relationship between the figure number and the number of circles you need to draw the figure? Can you make a formula which can calculate the number for circles you need to draw for figure number n? Pause the video here if you want to try to solve the problem yourself. A solution will come right away. There are several ways to look at the pattern that can solve the problem. Here is one of them. We can see the figure as circles at the bottom and at the top. To make it easier, we put different colors on them. In figure 1 we have 3 red and 2 blue circles. In figure 2 we have 4 red and 3 blue. In figure 3 we have 5 red and 4 blue. Do you see the pattern? To express the pattern algebraically, we often ask what the pattern will be when we get to figure n. The red numbers are always 2 more than the figure number, while the blue numbers are always 1 more than the figure number. Figure number n must therefore be red n plus 2 and blue n plus 1. We can add these together by adding the letters separately and the numbers separately. Then we get 2n plus 3. Another way to solve the problem is to insert the information in a table. In the column for pattern, we then try to rewrite the calculation in a way which include the figure number. This is often the key to creating algebraic expressions. To make it easier to discover, we have colored the figure number red. Can you see the pattern and how the calculation is rewritten? Such a table can be very useful when distinguishing between variables and constants in algebra. Constants are the numbers or values that are always present in all the figure numbers. In the column 4 pattern, you'll see that the numbers plus 2 and plus 1, which we have colored blue, are present in all the figure numbers. They are present every time. They are constant. The value that changes with the figure number is called the variable. You can find more growing pattern tasks for practice in the module. If you found this video helpful, leave a comment below about what you liked or what you found challenging. Happy learning!